What you got to do to solve this inequality here. So what we're going to do first is keep in mind that we're trying to isolate this variable. And what I'm going to do is I'm going to eliminate this term here. I don't want that. So to do that, you're going to use a zero pair, which means to do the opposite of what you see there, which is to be adding to. Because when you combine opposites, they cancel each other out. And you have to do the same thing you do with equations. You got to balance the inequality. So I'm going to add 2 to the other side. So I'll put plus 2 here as well. And now in the next step, I'm just going to simplify. So first thing I do is bring down my inequality sign. You can see here again, it's a zero pair. 2 negatives and 2 positives cancel each other out. They come out to be 0. That's why we call it a zero pair. And then we bring down the y. And then when I combine these two, 3 plus 2 is equal to 5. And you can see here, my final inequality would be y is less than or equal to 5. Next, I'm going to graph my solution set. So I'm going to sketch it out. I'm going to put 5 here in the middle, 6, 7, then you do 4 here, 3. Doesn't matter how many numbers you pick, but the main one we're interested in is this endpoint here, the 5. So the 5 would be a closed dot in this case. And the reason why I know that is because this line here underneath, it means equals. And as a side note, less than or equal to is really two different symbols connected. So it really means this. It means less than or equal to. We just combine it into one symbol. It's kind of like when you're text messaging, right? We put like LOL for laugh out loud because we want to abbreviate things so we don't put too much information down. So in math, it's the same way. We like to combine things together to make it more precise or more, I guess, pretty much less information. So you just got to know the meanings of it. So again, if you see this with the line underneath, it really means that, less than or equal to. So in other words, consider both. And on a graph, we do a solid dot to show that we're including that number, because that's what that inequality is saying. Any number you can pick could be less than 5 or equal to 5. So to show it could equal it, I put a solid dot. And numbers less than 5 would be to the left, right? 4 is less than 5, 3. But these are not the only numbers that are less than 5. Those are just whole numbers. But we also have numbers that exist in between. So all these like 4.1, 4.2, or 4.01, 4.999. So any number you could think of less than 5. So these are called real numbers. Decimals, fractions, all that is included. So I'm just going to shade all this in like this. And that's what that means. I could pick any number. And it goes on forever. So it's not just going to stop at 3. You could go all the way into the negative numbers forever, infinitely. And that's what this solution set means. So that's all you got to do to solve this inequality. You just got to use the addition property for the inequalities here.